Okay, we're going to move on to talking about optimization problems. To optimize something means to maximize or minimize some aspect of it. And then there's asking really like, so why is differential calculus such a powerful tool for solving problems that involve maximizing or minimizing? Well, hopefully based on what we just finished talking about with all this curve sketching, we realize that critical points are where the derivative is 0 or undefined, right? So it's related to the derivative. And that's where max and mins occur. And max values, maximum and minimum values occur at critical points. So if I had to summarize the main idea of this unit, it would definitely be all about these critical points. They're critical, one would say, because at critical points, and this theorem due to Fermat says that if you're going to have a max or a min, it occurs at these critical points. This is really the key. So if you have some situation, you have some problem, you're trying to maximize profit, you're trying to minimize the amount of materials you use to create some whatever, the maximum and the minimum values are going to occur where the derivative is 0 or undefined. So finding these critical points, this whole optimization problem, this whole idea is very necessarily connected to derivatives, differential calculus. All right, so we're going to start talking about some optimization problems. And for all of our optimization problems, we're going to follow these same 6 steps. So let's really emphasize this. Let's think about what they say. So first, what we're going to be doing is write one equation that expresses the relationship between your two applicable variables. There's going to be 2 variables. So one is just a relationship between these variables. It's like just a known fact. Again, often this is going to come from geometry or some other given fact or well, we'll see a variety of ways. And then the other equation you need is the equation you're trying to optimize. This is the thing you want to maximize or minimize. So this is the thing that you're going to find critical points on. Okay, so that means we're going to take the derivative, etc. But before we do that, we need to make sure that this equation we want to optimize only has one variable in it. So the next step is to use the relationship from step 1 to rewrite the equation from step 2 in terms of one variable. That way you can differentiate it and find critical points. And once you find critical points, you then basically have your list of potential maximum and minimum. So you sort of get rid of the ones that aren't reasonable and you solve for whatever variables are left. All right, so let's look at an example. This one's a pretty straightforward example. We're asked to find 2 numbers whose sum, which means add, sum is 20 and whose product is as large as possible, right? So we want to maximize that. So the first thing is to realize that the 2 applicable variables are these 2 numbers we're trying to find. So we can call those x and y. Those are my 2 numbers. I want to add these 2 numbers together, and I know the result is 20. So this is my step 1 equation, right? This is the equation that expresses a relationship between my 2 variables. This is not what I'm trying to optimize, right? What am I trying to optimize? So step 2 is to find the thing I'm trying to optimize. That is the product, right? I want to maximize the product. So the product, let's call it P, would be x times y. Okay, so to continue to step 3, what we have to do is use this fact right here to rewrite one variable in terms of the other variables so that x times y is an expression only using one variable. So it's equally easy to solve for x or y, it doesn't matter. So say if we subtract y from both sides, we get x equals 20 minus y. So I'm going to take this, substitute it in for my x, and so this process right here, this substitution is my step 3. So my product is 20 minus y times y. This is now what I want to differentiate to find critical points. As usual, I could do product rule or I could distribute, and so the product is really 20 times y minus y squared. So now when I differentiate, p prime is 20 minus 2y. Now, what are the critical points for, so all of this is still my step 4 now. I feel like this is kind of all over the place, sorry. But I need to now find critical points. So find, sorry, my computer was saving something. Find critical points. I need to know where p prime is 0 or undefined, but p prime is never going to be undefined. So I'm really just solving for where it's equal to 0. So if I add 2y over to the other side, we see that this is going to happen when y equals 10. So I don't even have any extra, I don't have any extraneous or unreasonable solutions. If y is 10, then I go back here, there's arrows all over the place, x is going to be 20 minus 10, so x is also 10. So what are the two numbers that are going to add to 20 but give me as large of a product as possible? That would be if x is 10 and y is 10.